velocity. This describes motion which refers to speed as well as the direction. We have already seen speed. Now, what does it mean when we say it refers to speed as well as the direction? To understand this, we need to have an understanding of another term called displacement. Now, displacement is the shortest distance between 2 points. And what does that mean? Let's say you remember your place is this and your friend's place is this, and we had done this type of exercise, remember? And here there was some kilometers here distance, here there was some distance, and here there was some distance. Now when you cover this on this path, the actual length of the path that you cover is called the distance, whereas the shortest path between A and B is called the displacement. So to understand this, conceptually, just think of that there is a ball here, right? Now it rolls over, and when it rolls over, it actually covers the shortest distance, right, to wherever it stops, right? So let's say it stops here. Okay, so this is the shortest distance. But suppose this ball, you have actually picked it up and kept it here first, and then you have kept it here, and finally you have kept it here. So actually you carried it in this sequence. So you have basically done what? You have displaced this ball from here to here. Yes, in this case it doesn't matter where all it went in between. So the displacement would be this. So this is A, this is B, and AB is the displacement. And this is very, very important, because in physics, in most of the places we use velocity rather than speed. So what is velocity? Velocity is the rate of change of displacement. So displacement by time. So for example, let's say you go from A to B, the distance is say 300 kilometer, and the time taken is 10 hours. So that means your speed is 300 by 10, which is 30 kilometers per hour. And what is the velocity? Velocity is 300 by 10 kilometers per hour, which is 30 kilometers per hour. But remember, we also have to mention the direction. So if he has gone from A to B, we have to say in the direction A to B, or generally speaking, we might talk in terms of north, south, east, west. Yes, so east, or we say due east, right? Or we might have an angle also. Now here there is, if we talk in terms of angles, it is 0 degree. Okay, in this case there was no difference between speed and velocity as far as the magnitude is concerned. Let's look at another example where speed and velocity will be different in magnitude. So let's say you are at point A, you have to go to point B. Now the way you go is like this, okay, and this is perpendicular. Here you take a turn at 90 degrees. This distance is, let's say, 3 kilometers, and you cover this in 10 minutes. This is 4 kilometers, and you cover this in 15 minutes. Okay. Now what is the speed going to be? Speed is going to be, remember, total distance. So 3 plus 4 kilometer divided by time. So 10 plus 15 minute. So 7 by 25 kilometers per minute. That's your average speed. Now velocity. Now the moment we talk of velocity, remember we are talking of displacement by time, and displacement is the shortest distance between 2 points. So shortest distance would be what? This. Now we have to figure out what is the magnitude of the displacement. So since we are given that it is a right angle triangle, we know we can use Pythagoras theorem to figure out AB. So AB is equal to, let us say this is C. We know AB square is equal to AC square plus CB square. AC square is 3 square plus 4 square. 9 plus 16. And this is equal to 25. AB square. So AB is equal to 5. Okay. Now let's substitute the value. 5 by 25 kilometers per minute, which is equal to 5 fives. So 1 by 5 is 0.20 kilometers per minute. So whether it is 5 by 25 or 0.2 kilometers per minute, it is the same thing. But compare it with the speed. What about the direction? Remember, we have to mention direction when we talk of velocity. So here you are at A and going towards this point. So this is north, south, east, west. So the direction would be southeast, due southeast. Okay. Now let's look at some other tricky situations. Let's say there is a park in which you have a circular track, and the radius of this circular track is, let's say, 1 kilometer, right? And you cover this entire distance in 2 hours. You start from here and come back here. What is the speed? Speed would be, distance is what? Remember, when we say distance, we are talking of covering the path. So that is a circle. So which means it is going to be, distance is going to be 2 pi r. So here kilometer, 2 pi r. So 2 pi times 1. So 2 pi kilometer. So speed would be what? Distance by time. So 2 pi by 2. So 2 pi is kilometers and this is r, which means it is going to be pi kilometers per hour. That is the speed. Now what about velocity? Now here we started from here and we ended up back here. So what is the displacement? Displacement is 0 kilometer divided by time, that is 2r. So which means your velocity is 0 kilometers per, yes. So velocity is 0 if you come back to the starting point. Now let's look at another case where you have the same track. The only thing is, instead of going full circle, you have reached the opposite end. So you started from A and you have stopped at B. Now the radius is, let's say, 1 kilometer, and it took you, let's say, 30 minutes to cover this distance. Okay, in this case, distance would be, full circle will be 2 pi r, but we are covering only half the distance, so divided by 2, so we get pi times 1 kilometer, that is pi kilometer. Displacement would be what? Displacement would be the shortest distance between these two, that is this, that is 2 times a radius. R is 1 kilometer, so it will be 2 kilometers. So now speed would be distance by time, that is pi by 30 minutes, which means half an hour. Pi kilometer and half hour. So which will be 2 pi kilometers per hour. Velocity would be, displacement is 2 kilometers divided by, and time is half, which is equal to 4 kilometers per hour. But in this case we have to talk of direction as well. So north, south, east, west. So here we are starting from A and going to B. So due west. Yes. So in case of velocity, you need to know geometry as well, right? Because the path that they give might be circular, it could be a rectangle, it could be a square, it could be a triangle. Say for example, if it is a triangle, the path could be like this. You start from here, A, you go to B, and from there you stop at this point, at the midpoint of B and C. So that means you have to figure out the altitude of this triangle. For that you should know the formula. So you need to know geometry in this case. I think that's enough for today. Bye for